What's up, guys? This is Jahangir from Edporium, and today we're going to be talking about uniform circular motion. So, uniform circular motion is what you think about when either you're driving across a curve or you're pretty much moving in a circle, hence the name uniform circular motion. Now, this uniform part comes from the fact that it is an object, so I'm going to write the definition here. It's an object. So object at a constant speed. So uniform circular motion is when an object is at constant speed with acceleration being perpendicular to velocity. And we will have acceleration because our velocity is changing direction. So what is this going to look like? How can we visualize uniform circular motion? So I'm just going to draw a circle right here just to show our car pretty much moving in a circle. So let's just say this is our car. Let me switch my font over here. So what this is going to look like is if our car is right here, our acceleration is always going to be radial, so it's always going to be pointing to the center, and our velocity, which we said is perpendicular, so this will be acceleration over here, velocity is going to be perpendicular to that, and this is our velocity. Now, as this car is moving from this point over here all the way around the circle, this velocity is continuously changing direction. And because of this change in direction, that is why we have acceleration. So as the direction of velocity is changing, that's when acceleration is produced. This acceleration over here is going to be denoted as a radial, or you might also know it as centripetal acceleration. So I'll just put centripetal A. So this is our centripetal acceleration because as you can see, and let me just move this acceleration a little bit closer to the center. If this is the center of our route, you could say, or pretty much circle, that's where acceleration is going to be pointing to the entire time. And if we move somewhere over here, acceleration will still be pointing to the middle of that path, and our velocity would be perpendicular to that. So acceleration is still over here and velocity would be over here. So remember, acceleration and velocity in this uniform circular motion, those will be perpendicular from each other. And our equation for our centripetal acceleration or our acceleration or radial acceleration is going to be our constant speed over radius. Now, the reason why we're putting speed instead of velocity is because velocity has direction. Remember, velocity is a vector, speed is a scalar. So since velocity has direction, we're going to have a negative and we're going to have a positive. So that's why we're just going with speed. Because if we look at this diagram over here, I'll just draw it out over here showing velocity being perpendicular to acceleration over here. And let's just say this is the middle of our circle. We could say the radius, and this is acceleration radial, our radius is going to be this point over here from our car position all the way to the center of our circle, I guess you could say. So now let's go through a practice problem that really details uniform circular motion and how to find our centripetal acceleration. Let's look at this practice problem, and it states that if the maximum centripetal acceleration that can be attained without slipping out of a circular path is 9.8 meters per second, what is the minimum radius of the curvature the car can tolerate, assuming the curve is unbanked, giving a constant 45 meters per second. So first off, with all of our practice problems and with any problem that we're dealing with physics, we have to write down what we're given. So we're given a constant speed of 45 meters per second. So we're not talking about velocity, we're talking about speed. Speed doesn't have direction, so we'll just say our speed is 45 meters per second. So this is our speed. And we know our centripetal acceleration is going to be 9.8 meters per second squared. So it's asking what is the minimum radius of the curvature? Well, if we remember our equation of the acceleration of the radial, so a rad equals constant speed over radius, we have constant speed. We have the acceleration. All we have to do is find the radius. So if we manipulate this equation towards our benefit, we can move radius to this side, and this will be constant speed over acceleration. The radial acceleration is going to equal radius, and this is just going to be 45 meters per second squared over 9.8 meters per second squared And when you do all the math, and with most of these practice problems, I'm just skipping through the math so I can get right into the answer. And when you do the math for this one, you're going to get 207 meters. So that is the minimum radius that the car can tolerate in order to have this centripetal acceleration of 9.8 meters per second squared going at a constant speed of 45 meters per second. Alright, so now let's look at our final practice problem, and it states a carnival ride has a radius of 5 meters and moves at a constant speed, making a full circular motion or circular rotation at t equals 4 seconds. Now, what is the acceleration of the passengers? So I want you guys to pause this video and see if you can answer this question on your own, and as a sort of a hint, I'll give you guys one of the equations that you need since you're only given time and you're not given your constant speed. You're not given a specific constant speed, so your constant speed is going to equal 2 pi r over t. You guys know what radius is, you guys know what time is, so use this equation as well as our equation for finding centripetal acceleration in order to answer this question. So just like every one of our practice problems, we need to write down what we're given. So we're given our radius, which equals 5 meters. We're given time as well, which equals 4 seconds. And we're trying to find our acceleration of the passengers. Now, the reason why we know this is centripetal acceleration is because if we can sort of visualize what a carnival ride may look like, what this ride may look like, we're obviously going to form a circle. And what happens is there's going to be these passengers that, let's just say this is passenger, there's a passenger over here, and they're going to be sitting on like a swing or something. So it might be something like this where the passenger might be sitting on this type of swing, and this chain over here connects to the middle of that carnival ride. It's going to be a chain that's holding a passenger. So this is our radius, and this is, as the question states, this is 5 meters. Now, to make a full circular motion, that takes 4 seconds. So to find, and it states that we're at a constant speed. So we automatically know that this is uniform circular motion. When the question states that it's a constant speed, and we know that we have some sort of centripetal acceleration, that's when we know it is uniform circular motion. So since we know that, we need to find our constant speed, what that velocity is, because our equation for centripetal acceleration depends on constant speed over our radius. So over here, we know our radius, we know our time. So this is 2 pi, radius is going to be 5 meters, and this is over 4 seconds. And when you do the math on this side, you're going to get 7.9 meters per second as our constant speed. And all you have to do is just plug it into our equation over here. So the 7.9 meters per second, this is going to be squared. This is over 5 meters. And to do all the math for that side as well, you are going to get 12 meters per second squared. And one thing I highly encourage you guys to do is double check your answers by plugging in your centripetal acceleration and trying to find radius, for example. And when you do that, you're going to see that when you plug in your centripetal acceleration to find your radius, this is going to be 7.9 squared, so that's 62.41 divided by 12, and you get 5.2, which is very close to 5 meters. And if you have a multiple choice question and there's only like 12 meters per second and every other answer is just much more different than that, then you know the answer is 12 meters per second squared. So that was sort of an introduction to uniform circular motion, and further on in our videos we're really going to dive deep into this circular motion. But that's pretty much it for this video. Hopefully you guys learned something, and as always, a Pomodoro a day will make you a doctor someday. I'll see you guys in the next one.